Imagine if I told you that around 74,000 years ago, humanity was reduced to perhaps just a few thousand survivors scattered across Africa. What could possibly bring our entire species to the brink of extinction? The answer lies in one of the most catastrophic volcanic eruptions in Earth's history, the Toba supervolcano. Deep beneath what we now call Lake Toba in northern Sumatra, Indonesia, lies the remnant of a geological monster. This wasn't just any volcano, it was a supervolcano, a rare and terrifying force of nature capable of altering the planet's climate for years. When Toba erupted 74,000 years ago, it unleashed devastation on a scale that's almost impossible to comprehend. To understand Toba's power, we need to grasp what makes a supervolcano different from regular volcanoes. While ordinary volcanic eruptions might spew millions of cubic meters of material, supervolcanoes can expel thousands of times more. Toba's eruption ejected an estimated 2,800 cubic kilometers of volcanic material into the atmosphere. That's enough to bury the entire state of Rhode Island under 300 meters of volcanic debris. The eruption began when the massive magma chamber beneath Toba finally reached its breaking point. The ground above collapsed, creating what geologists call a caldera, a massive crater that today holds Lake Toba, stretching 100 kilometers long and 30 kilometers wide. But the real destruction came from what shot into the sky. Volcanic ash rocketed 32 kilometers into the stratosphere, far higher than commercial airliners fly today. This wasn't ordinary ash. It was a mixture of pulverized rock, glass shards, and toxic gases that began spreading across the globe. Within days, ash clouds had circled the Earth, blocking sunlight and beginning a volcanic winter that would last for years. The immediate effects were catastrophic. Ash deposits up to 15 centimeters thick blanketed much of Southeast Asia and India. Scientists have found Toba ash layers in sediment cores from the South China Sea, the Indian Ocean, and even as far away as Lake Malawi in Africa. This ash suffocated plant life, contaminated water sources, and made breathing nearly impossible for any creature caught in its path. But the ash was just the beginning. Sulfur dioxide gas from the eruption formed aerosols in the stratosphere, creating a reflective haze that blocked solar radiation. Global temperatures plummeted by an estimated 3 to 5 degrees Celsius. This might not sound dramatic, but it was enough to trigger a volcanic winter lasting 6 to 10 years, followed by a 1,000-year cooling period. During this time, much of the northern hemisphere experienced near-glacial conditions. Tropical rainforests withered and died. Monsoons failed across Asia and Africa. Food chains collapsed as plants struggled to photosynthesize in the dim, ash-laden atmosphere. For early humans who were already living in small, scattered populations, these conditions created a survival bottleneck of unprecedented severity. This is where the story becomes particularly fascinating for our species. Genetic evidence suggests that around this time, human populations crashed dramatically. Some researchers propose that our species was reduced to as few as 3,000 to 10,000 breeding individuals, a population so small that we nearly went extinct. The evidence comes from studying human DNA diversity. When scientists examine our genetic makeup, they find what's called a population bottleneck around 70,000 years ago. This means that all modern humans descend from a relatively small group of survivors who lived through this period. Some researchers directly link this bottleneck to the Toba eruption, though this connection remains hotly debated in the scientific community. Not all scientists agree that Toba nearly wiped out humanity. Some argue that early humans were more resilient and adaptable than the catastrophe theory suggests. Archaeological evidence from sites in India shows that human populations may have recovered relatively quickly after the eruption. Others point out that similar genetic bottlenecks occurred in other species during the same period, suggesting broader climate changes rather than a single volcanic event. What's not debated is Toba's massive impact on Earth's climate and ecosystems. The eruption ranks as a Volcanic Explosivity Index 8 event, the highest rating on the scale. It was roughly 5,000 times more powerful than Mount St. Helens' 1980 eruption, and 100 times larger than Mount Tambora, which caused the year without a summer in 1816. Today, scientists monitor supervolcanoes like Yellowstone and Campi Flegrei, knowing that while such eruptions are rare, they're inevitable parts of Earth's geological cycle. The Toba catastrophe reminds us that our planet's history is punctuated by events so powerful they can reshape the course of evolution itself, turning near extinction into the crucible that forged modern